Kimberly Carver. I'm the art librarian, and it's my pleasure to introduce to you today Darryl Lauster. Darryl is an intermedia artist and an assistant professor of sculpture here at the University of Texas at Arlington. He was the founder of the Samuel Gray Society, an institute dedicated to the 18th century American history. His work is based in research of American history and mythology and utilizes digital media, printmaking, sculpture, and installation. He's exhibited nationally at the Louis Wells Cameron Museum of Art, the Urban Center for Contemporary Art, Appalachian State University, Millennium Plaza Park, Contemporary Art Museum in Houston. His work can be found in permanent collections of the Philadelphia Museum of Art, the University of Texas at Arlington, McNeese State University, and the Museum of Fine Arts in Houston. He's the 2010 recipient of the Joan Mitchell Foundation grant for painters and sculptors, and also has received grants from the Peter Reed Foundation and the Houston Arts Alliance. He served residencies at UCross Foundation, the Wasaic Project, and the Vermont Studio Center, and the Birdcliff Art Colony. His upcoming endeavors include participation in Sculpture Key West, an international outdoor sculpture exhibition, and in June he will participate in an international residency program in Rutten, Holland. It's my pleasure to present to you Darryl Lauster.
Thank you for being here, folks. I'm going to talk to you today about a project that I'm extremely proud of and was honored to complete for President Spaniolo. And it involves the first outdoor public sculpture presented on this campus. And it's titled Reach, and it's in the quad, the Greene Research Quad of the engineering building. I imagine many of you, if not all of you, have had the opportunity to see it. And it's my goal today to talk to you a little bit about its inception, its inspiration, and ultimately its construction, which was quite an endeavor. When I was asked to submit an idea for this project by John Ball and President Spaniolo with the help of my chair, Robert Hauer, I wanted to create an object that would provide a synergy between art and engineering. I knew that the site was going to be within the engineering wing of the university, and of course, as the artist, I wanted to create a tie between those two disciplines, which of course are related. After some time, while it's a bit out of my standard research area, which involves 18th century American history, I started to lock in on the gentleman you see projected here, Leonardo. Leonardo's an interesting fellow who many young artists learn a great deal about early in their academic careers. But I, like many artists, allowed him to kind of fall out of my head because, of course, there's 500 more years of history to learn after Leonardo. And I found myself reinvestigating the legacy of this incredible thinker and artist and engineer, mathematician, botanist, cadaver dissector, and many other things. And I found that he was the individual who I wanted to use as the linchpin for this project. And as I began looking at Leonardo again, I focused on some of the highlights of his career and legacy, and I wanted to offer a snippet of that for you all today, just to give you an idea of the interdisciplinary nature of his interests and research. So he was born in 1452. In 1466, at the age of 14, he apprenticed to Verrocchio, one of the great masters of the early Renaissance in Italy. He was a painter. From 1482 to 1499, he lived and worked in Milan and painted Virgin of the Rocks and The Last Supper, two of his most well-known works. He also, at the same time, this is, love this man, was designing military weapons and machinery for Duke Ludovico Sforza, who was the Duke of Milan at that time. In 1485, he traveled to Hungary. Between the approximately 30-year period of 1489 to 1518, he wrote many treatises on a variety of subject matters, from botany to cartography, flight, zoology, sculpture, painting, philosophy, and in fact humor. So within the figure of Leonardo, what I think we have is the genesis of the modern university in many ways. All of the interests that Leonardo researched throughout his life are invested by departments at UTA and of course universities across the globe. And so I find him to be a very pivotal figure as I began to think about not only my place at this university, but this project that was uniting two disciplines, which of course are related but are also distinct. I felt that I needed to do something here, and I needed to use this man as the cornerstone of the project. In 1502, he becomes the military architect for Cesare Borgia, also meets the both famous and infamous Niccolo Machiavelli at the time. He also designs a bridge to span the Golden Horn in Istanbul. 1505-07, paints the Mona Lisa. Contributes to Luca Pacioli's Divine Proportion, which is a treatise on mathematics. And so you can see that one discipline could not easily tie this man down. His interests were varied and wide, and I wanted to incorporate one aspect of that into this object. So the question then becomes, how does an artist do that? I began to look at the artistic legacy and the design legacy of Leonardo da Vinci, and some of those very well-known works I have here for you to show you. This is his so-called Vitruvian Man, wherein he's charting mathematically the proportions of the human figure. This is one of his lesser-known schematics for a giant crossbow. Just to show you the scale, there's a figure. So, I mean, this is, in essence, what he's creating is the first ballistic missile here. The arrow for this would have been more than likely 25 feet long. Never built. Most of Leonardo's designs were never built during his lifetime, and while I can never know this for sure, I tend to believe that he knew this. He knew that they would never be built in his lifetime because in many ways his ideas were outpacing the technology of the era, which was predominantly iron, wood, and fabric. This is one of his schematics for a machine to build a machine, which is something that I'm very interested in artistically. I like the idea of building a machine to build another machine, or using a tool, creating a tool to make another tool. This particular machine is used to chart the slope of a stave, which is used to create a cannon. In the Renaissance area, cannons were made of iron, but they were built in much the same fashion as the old whiskey barrel. So you had these planks of iron, which were then crossed with hoops, which kept its shape. And this object would allow one to draw and chart the appropriate arc of a stave in order for it to be very, very solid and massive at one end, and then taper to the end where the ballistic would leave the cannon. As opposed to some of the military apparatus or some of the other designs or schematics that Da Vinci created, I locked on to the design which is typically referred to as his aerial screw. It's often reflected and discussed as the first proto-helicopter. That is moderately true. Obviously, the design has changed significantly. But the aerial screw is a design in which Leonardo believed would fly if spun at a certain rate. The idea is that the sail, which moves in this helical pattern, would allow the object lift once spinning rotationally. It's believed that this object would never work, largely because of the materials of the time. They'd be just simply too heavy. This would have been made, if it were made in Leonardo's lifetime, with wooden timbers, and the sail itself would have been a linen similar to the canvas that Renaissance painters were using in the era. But I like the design very much. I liked its vertical thrust. I like symbolically the idea of flight as it relates to the acquisition of knowledge. And so I began thinking predominantly about this design and the way that I might appropriate it to create my sculpture for this university. So that word appropriation is, if you ask an artist what it means, they'll say, well, it's a nice way to say steal, right? But in fact, the word appropriation refers to an act of, well, borrowing, shall we say. But it's behind that idea is the nature of the act as an homage. And so it is a borrowing that is, first of all, apparent and pronounced. And secondly, it's typically one wherein an artist uses a pre-existing form to speak in some way to the history of that form, but then also place his or her signature upon it and push it into the future in a new way. Okay? So it's not something done under cover of the night. In fact, it is most often an homage in which the artist maintains a connection with the prior form and then moves it into the future through his or her own vision. And so I wanted to appropriate this object and pay it an homage. Not only as an artist, it's obviously something Leonardo is someone very important to my own legacy as an artist, but obviously his legacy is beyond simply the discipline of the arts. And I wanted to choose this work both for its symbolic qualities, but also I wanted to offer it as the possible incarnation of this object, which was never, of course, built in Leonardo's lifetime. So, what happens? And how does that, let me, just before I go farther, just give you some visual examples of the way appropriation works in the way that I'm talking about. I'm sure you all recognize here Thomas Jefferson's library at the University of Virginia, right? This is an appropriated building, and there's a reason that Thomas Jefferson's library looks almost identical to the Pantheon in Rome. It is meant to be an homage to classical architecture, but of course, Jefferson is changing, in this case, scale, materiality, and function of the building to push it forward into the future in a new way. So it is both a look backwards, and it is both a look forwards at the same time. Appropriation is also the same reason that our monument to Washington in DC looks very much like this New Kingdom ancient Egyptian obelisk that can be found in Karnak, right? So it again is a nod to the past, but also moving into the future with a new function, new materials, new presence. So this is my mindset when I'm looking at this object right here, the aerial screw. So how does it all begin? It begins with some designs. And to be honest with you, a project like this begins with a lot of help, a lot of really, really, really good people who are good at what they do, working towards the same goal in support of me. And something like that is very humbling. I was very humbled by the support I received on this project from the administrative levels of this university to the contractors that I used for the work. Everybody got in on this project. And I think one of the reasons that they got in on this project is because Leonardo's legacy is such that everybody wants to tap into it in some way. I mean, he's a guy, how could you not aspire to something, you know, like, to putting your signature on something of his in some way. And so I was very humbled by the great support I got on this project. It begins with a model. And what you have here in this photograph is, on the left is my engineer, who is going to be doing all the math on this project. And on the right is Brian Sims, who works with the university's facilities department. Here is a model of Leonardo's actual object in 3 dimensions. And then to the right is the model that I've designed. So there have been some changes, right? One of the changes that I wanted to make immediately was materiality. As I mentioned, Leonardo's piece would have been built out of raw timber and linen. I wanted to create something that marked the contemporary era in which I work, and I chose aluminum. I chose aluminum partly because on a practical level, it's light and it withstands the elements. On a symbolic level, I also chose it because it is a material, it's an alloy, that is often used for aircraft and involved with flight, and also for military applications. And beyond that, many, many applications in our day-to-day kind of life. So it's a rather ubiquitous material that it's around us everywhere, in this room, out of this room, and of course it also is represented in the building of the engineering research building itself. So I chose aluminum for several reasons, and they're both practical and symbolic. One of the things, now this was never going to move, okay? That was clear, that even though Leonardo's design would have been kinetic and it had a practical function of flight, this was going to be a static object. So one of the things I wanted to do was to imply movement without actually the function of movement. And so I began to look at the sails, and I stripped every other sail out of Leonardo's design, creating both a positive and negative space that intersects throughout the linear aspect of the work. But also I wanted to create great shadow play on the base and around the object as the sun moves through, or as we orbit the sun. The shadows will change and move throughout the geography below the sculpture. So I felt that the moving the sails to an every other kind of orientation implied movement to a greater extent than having the sails complete the entire circumference of the helix. There are a couple of other things that happened, okay? Leonardo actually provided a measurement for his aerial screw. That measurement was 8 brachia wide. Anyone know what a brachia is? I had to look it up. Yeah, it's the length of a man's arm. It's kind of a measurement unit I'd like to see come back, actually. It's pretty cool. But obviously what it also entails is a lack of specificity, right? Because men's arms tend to be slightly different lengths. And by men, would that also mean women? Is that just men? I don't know. But most scholars would agree, or do agree, that 8 brachia is roughly 15 feet. Okay? So the entire diameter of the sail of Leonardo's original aerial screw was 15 feet wide. That's fairly small, and the space that I had to work with is significant in scale. So one of the things that I wanted to do immediately in order to give this object some presence in its environment was double the scale. So I originally started making drawings that were defined with the parameters of 30 feet wide by about 32 feet tall. And that was based roughly on doubling the size of Leonardo's original design. That's when the engineer comes into play. And the engineer on this project is responsible for ensuring that the object has the structural integrity, the tensile strength necessary for it not to fall, and also to withstand things like 90-mile-an-hour tornadic winds and other kinds of concerns. So my engineer is looking at my design, he's doing the math, he's also plugging in the material, the material that I'm using, which is an aluminum alloy, and that of course has its own, it has its own tensile strength, it has its own malleability, so there are a lot of things that are going into the engineering of this that I'm not necessarily involved in once I pass off the design. However, I tell you this story because, first of all, everyone has a role in this, but secondly, because of the engineering requirements of the object, my dimensions had to change. Okay? So one of the things that happened is that my sculpture became 24 feet tall and 28 feet wide. And that was just based on pure math. It's what had to be done. For me to use aluminum to stay within the stock that I wanted to use, and of course that equates to money, right? So I have a budget, right? And I have to do this with this amount. And in order to do this with this amount, some modifications had to be made in the object in order for it to be engineered properly and receive a stamp. Okay. So the object now, from the engineer, is coming in at 24 feet tall, 28 feet wide. We've got the materials down, we've got the dimensions down, and now it's ready to go to the fabricator. Once the engineer stamps, the engineer begins working directly with the fabricators that I use who are working with me, and they are Root and Metal in Dallas. So this object is actually being built by a team of people in Dallas, and I am going back and forth every day, working with them, and then working the construction which is taking place here at UTA. Because as the sculpture is being built, the foundation is being constructed here on the campus. So from this point on, what I have are photographs of the project in action, of it being built in several different stages, both the sculpture and the foundation and all things that have come to be a part of it, including the walkway, the masonry work, the lighting. So at this point, I'm going to have some fun. So the project begins, as many projects begin, with a groundbreaking, right? It is, I mentioned, 24 feet tall. It actually goes 15 feet underground as well. So this object, because of its weight, it weighs about 5,000 pounds, which is really not much for a public sculpture or even for a structure. But because of the composition of our soil here in Texas, which is very clay, it's very heavy with clay, 5 piers have to be drilled into the ground 15 feet deep in order for this object to withstand those 90-degree tornadic winds. And so the depth of the piers, in essence, insulates the object from being blown to the side. So the first thing that has to happen are these piers. 5 15-foot piers are drilled into the ground with this giant auger, and you can see it pulling up the dirt. And then they have this fascinating object that they put at the end. Once the 15-foot core hole is drilled, they have this really fascinating piece of engineering that they put on the end of the auger. And what this does is it carves out a bell at the bottom of the hole, so that the bottom of the hole is the widest point of the hole, adding greater stability at the base. So I include that here because I just thought that was the coolest thing. And then the holes, of course, get filled with rebar before they are poured with concrete, which reinforces the concrete. And then it's time to pour. And I have a great construction crew working with me here. This is Nouveau Construction, who do many of the projects on this university. They were involved in the building of the engineering research building itself. So they were actually really excited about this because they had never done anything before like this. They typically do purely functional kinds of stuff. And so they were very excited, and I had lots of great conversations with these guys about this object. And so the piers get poured. At the same time the piers are getting poured, my material has been ordered, and it's arriving in Dallas at my manufacturer. And it looks very humble at this stage, I know. But everything begins with the smallest of steps, right? So the material is coming in stock. It is hollow aluminum, and the wall thickness of the aluminum varies from, in terms of the mass, the thickest is 1/4 inch thick, and the thinnest is, the thickest is 3/8 inch thick, and the thinnest is 1/4 inch. So it's hollow, but it's also got substantially thick walls, so it's very, very strong. This is the center mast of the object coming in 2 pieces, which will be welded together to create the 24-foot length. If you look closely, there's a little drawing of my object here on the ground with footprints all over it, which is kind of nice. So my material is arriving, and at this point, my job is largely coordinator, right? I'm going back and forth to Dallas practically every day, and I'm dealing with the fabrication of the actual object in this large metal shop. And then I'm coming back to the university, and I'm not necessarily supervising, but I'm certainly there to watch the construction and the fabrication of the foundation, the piers, and the seating ring that ultimately will be a part of this object as well. And here is an example of what that seating ring looks like as it's being cast. So from above, the object I mean, it looks pretty damn cool actually right now, doesn't it? I kind of missed all of these pieces of wood and all the framing and all the braces and all the molds when they went away. But you can see that the construction of the site I mean, it looks like a construction zone at this point, and it will for a very, very long time. We've got large machinery moving in and out. There's a workforce of about 12 to 15 people on any given day working on this object. And the foundation is actually a really, really important component of the work. It's not often that we think about that, but you know, if I put this sculpture on something which was not substantial enough and did not convey a sense of invitation that I wanted, that is expressed through the seating ring, it would have failed. Right? So each is equally important to me at this point, and both are going on in different places. The way that I've engineered, if you'll recall the original design, let me go back here really quickly to Da Vinci's drawing. So if you see Da Vinci's drawing, it's largely divided at a center point if you look vertically, if you measure vertically. The top half of this object is dedicated to the sail. The bottom half of the object is dedicated to this tripodal structure, which is of course ringed with a circular paved way where individuals would have been rotating the mast with these arms that radiate out of its center point. So roughly at the top half you've got sail, at the bottom half you've got structure, and I wanted to key in onto that bottom structure, but also in a reductive manner that was a little lighter, which of course I can do because I'm using aluminum and not timber. And so I created a tripod base which would lock in the bottom of the object visually, but it would also secure the object from an engineering standpoint and bear much of the load that would be pressed upon the mast as it blows in the wind, because aluminum actually moves quite a bit. It's if you're there when the object with the object when there's a good wind, it will move, and that's understood. But this tripod is something that locks the object in and makes it very, very strong, as much as it is as an important aesthetic feature. Because it was so important to the structure of the object, we decided that it would be on site when the concrete was poured so that it could be cast into the concrete in exactly the right spot. Because if it were off by just a half an inch, it's all over and everything would have to start again. And so here's the first part of the object which was built is the tripod for that very reason. And here it is coming to campus and being unloaded by some very good coworkers. I'll come back to that in just a minute. And so here is the base now, which is prepared to receive the concrete. And one of the things that you'll note, first of all, things have gotten very complicated, which you can imagine. And one of the reasons is because the lighting is now a consideration. And the lights of this object are embedded in the concrete and shine up through the sails. So all of that has to be measured, put into place, and ready just like the tripod when the concrete is going to be poured. And you've got one shot to do this, and if it's off, it all has to start over. So here's my lighting engineer on the right, and this is Nick, the project manager who works with us at UTA. Wonderful guy who was very helpful in this project on the left. And the lighting manager is there to ensure that these lights are placed exactly where they need to be, because again, you've only got one shot here. If it's off, it's not good. And so here is the tripod now on the form, and the 6 lights that you see around it, those little blue circles, are the lights. And then here comes the concrete. So let me go back now and show you the aerial shot. So this is from the top of the ERB on one of their really beautiful patios. And the other thing that's been incorporated into this object is a walkway that makes it invitational. I want this sculpture to be a place of commune. And in so wanting that, I created a seating ring on the exterior of it, And I also asked for a walkway that would then come from the existing sidewalks to the object so that it would appear to be more inviting. I want this object to be a place where students gather. And so you see that the framework for that walkway is now in place. And here's a slightly closer view where you can see the tripod also resting on top. So the concrete gets poured. At this time, the masons are also cladding the concrete that's already cured in limestone to match the building. And the sculpture is taking shape in Dallas. All this happening at once. I didn't get a lot of sleep for a couple of months. But the gentleman in this photograph is Bobby Reed, who is the supervisor for the construction of this object. And this group of 5 individuals banged this thing out in 5 weeks. And they do it all by hand, primarily, with the help of pneumatic machines. But the welding is done by hand, the buffing is done by hand. These guys are master technicians who I've worked with in the past on smaller projects, but never something to this scale. And in fact, this is one of the largest pieces they've ever done as well. So it was a really nice moment for us both in that we were both doing something that was really pushing our limitations. And I could not be happier with the results. So you see what's happening here is that the radiating arms, which are going to receive that helix, are being attached to the central core mast of the sculpture. Because this sculpture was being built in Dallas and had to be shipped to Arlington, it had to be engineered and designed in such a way that it was modular, right? It has to come back apart so you can actually travel it on a large semi to get it here. And so what you're seeing here in this photograph is a close-up, and you probably can't tell from the projected image, but what they're doing is they're threading the aluminum. And so the ribs, or the arms that radiate from the center mast of this, are actually 2 pieces of aluminum that are threaded into each other to create its proper length. At the same time, the helix, which is going to tie the exterior of the piece, is being fabricated out of 12 different aluminum round bars. Because the helix itself is not consistent, it starts at a narrow point and grows wider as it proceeds down the sculpture. All of the math of these is different, and each one has to be numbered and marked, and if they get confused, the whole thing has to get taken apart. It's like a puzzle. And because of that, the fabricators in Dallas decide that they're going to actually mock this thing up and build it on site where they can troubleshoot any problems before it comes here. So it actually gets erected twice. It gets erected in Dallas, in the metal shop here, and that's what's taking place in these photographs, because they want to ensure that there are no problems, which was a very good idea because there were a few tweaks that had to be made. So here are some of the, and also they're not seeing this together yet either. So this gives them the opportunity to see the object in its totality as opposed to simply in pieces. And you can see that outer helix taking shape here. And I got really excited at this point because this was the first time I was seeing it as well. It was a really nice moment for everyone because we had seen drawing after drawing after drawing and part after part after part. Suddenly things were taking shape quite literally. And here it is, just about complete. It takes about 2 days with 4 people to erect this object. So, now it's up, problems are solved, it exists, the math is right, it's standing, everything's good, right? So now it has to be taken down, it has to be taken apart, and then traveled to our university, right? So here it comes, it's arriving, and one of the things that happened here is that this is kind of at the tail end of the spring semester. So what's nice is that there's not a great deal of students around. Not that that would have been a problem, it just made things a little bit easier to navigate these large trucks into the area. So here it comes from Dallas, and at this point, a crew of professional art handlers who work here in Arlington take the object and they're going to erect it on site because this is what they do. This is their job, and they do it for museums in the area as well as across the greater region, which enables me again to just kind of take a supervisory role and help when needed. And they bring in the gantry crane to roll this object in here, and then later a genie lift. As I mentioned, the fact that it's 5,000 pounds allows for lighter equipment. If I decided to make this out of stainless steel, it would have weighed 3 times as much, and we would have had to have a crane come in, which would have, I couldn't even tell you how much more expensive that would have made it. So the gantry crane and the genie lift are able to handle the weight of this object along with a couple of crew. And you can see here that it's being lifted up on top of the foundation where it will be bolted to the bottom. And then you'll notice that the tripod has been taken off now, and it's going to get locked into the sculpture once and for all momentarily. So here comes the tripod now, one leg at a time, just like putting on your pants. And then the arms are beginning to take shape, and then this wonderful moment, the first fabric triangle got put in. I have taken it upon myself to do the installation of the sails. I've been calling them sails. I've been using a lot of nautical terminology to describe this object. I'm not sure quite why, but it just feels right. So I've taken it upon myself to do the sails, but because of the way in which the object becomes wider as it goes from top to the bottom, in order to maneuver the equipment around, I have to do the top sails before the object is fully made, because I'd never get up there again with the equipment that we have available. So the first sail goes up rather quickly, and it's a really nice moment because, again, even though I've seen this object construction in Dallas, we didn't do the sails because that wasn't under their purview. So I was able to get up there and put a sail on, and that was kind of a nice moment for me. And then the object continues. And then here I am, up inside. The object is largely constructed at this point, and I put on 3 sails, and then it gets finished, and then I do the other 9. And the way that I'm doing the sails is actually, I mentioned I've been using nautical terminology. I was thinking a lot about how I would attach the sails to this object. And after a lot of research, what I realized was that the simplest way was the way to go. And I used a very simple system of lashing, and the only knots that I tied were constrictor knots, which are a very important knot for sailors. And then the constrictor knot, just for my own security, was then it was reinforced with a rope tie, a rope clamp. So you've got a constrictor knot and then a redundant device, the rope clamp, to make sure that if for any reason the constrictor knot would fail, the rope clamp is there to keep it as well. So you can get a sense of the articulation of the spectra cord, which winds around the object and through the grommets of each sail in a very, very simple way. And then here it is from the top of the genie lift as I'm leaving it. And here she is today. You'll see the seating ring around the center foundation, which supports the object, and of course, as I mentioned, goes 15 feet into the earth. I mean for this object to be interacted with. I hope that all of you have the time to sit and hang out with it for a little bit of time. I have tried to create something which is both aesthetically pleasing, by chance perhaps even beautiful, but more importantly, that is in a particular scale which is comfortable to the human body and approachable and accessible. And there's a softness to both the color and the materiality that I hope is inviting as well. This is one of the most beautiful spaces on our university campus. and I'm really proud to add this addition to it. That's about all I have, folks. Thank you.